Hi everyone. Today we're going to talk about the mathematical concept of variation. So we're going to write equations that have variation in them. We're going to solve equations that we set up. So there's three types of variations we're going to look at: direct, inverse, and joint variation. So variation has the word vary in it, which means to change. So in all of these cases, we're dealing with two or more variables that one changing affects how the other changes. So direct variation, they both increase together, or both variables decrease together. Inverse, invert means to flip, so as one variable goes up, the other one goes down. And then joint variation is a little more complicated because it's got generally three or more variables where they're all acting in harmony. So we got to see what happens as one variable goes up, how does another one change? So here's an important table to fill out as we look at the formulas, the features, what is happening for direct, inverse, and joint variation. We also have to look at this concept called the constant of variation. So constant of variation is a constant in a formula that stays the same as the variables are changing. So it's the only part of the equation that stays the same. So in this case, for area of a triangle, area equals 1/2 base times height. I don't care what the base or the height is. Those help to determine the area, but this 1/2 is always in our equation. And that's the constant of variation. Now, direct variation looks like this, where if we're nannying over the summer, okay, we get $250 per week. So after week one, we get $250. After a total of 2 weeks, we get 250 and another 250, so we get 500. After another week, we get 750. And we keep adding 250 per week. And as the weeks increase, the total amount of money made increases. Now, the equation for this is T equals 250 times W. So 250 in this case is our constant of variation. And if we multiply that by how many weeks, we get the total amount of money made. So this is a linear equation with a positive slope. Direct variation is linear with a positive slope. Inverse variation is an example like this. We have an area that's 24 square yards. So we could have a length of 1 and a width of 24. So we do 1 times 24, or maybe 2 times 12, 3 times 8, 4 times 6. And notice, as the x's increase, the y's decrease. So as one variable goes up, the other one goes down. Now, I can't have a constant variation that says 1 times something is 24, because 2 times the same number is not 12. So in this case, the variables are on the same side, and the constant of variation is the area. So 24 equals length times width. As length goes up, width goes down. And then joint variation, we need three variables. So we have this case where the volume equals length times width times height. And in this case, I told you that the length is 20, so that's the constant. That stays the same. Now, if width goes up, volume's going to go up. And if height goes up, volume goes up. So this would say volume varies jointly with width and height. So if either width or height goes up, then volume goes up. Now here's a nice table to help you remember it. Okay, which ones increase together? Which ones act differently? So if x goes up, y goes down, that's inverse. And then joint variation has at least three variables all interacting with each other. And that's the three types of variation.